After 5 amazing years of Unity development and a ton of C# wizardry, it's time for a change. After surfing the web, forums, and talking to ChatGPT, it is time for a new engine, the Flax Engine. Hosting a ton of useful features and an amazing resemblance to Unity, it is the most likely candidate to take its place. Forget Godot and Unreal, and let's take a look at the Flax Engine. Alright, so once you have installed Flax Engine, we can create a new project by going into the Projects tab. You create a new project. We're going to create a blank project. We're going to call this Flax for Unity Devs. Create project. It is listed here now. We go into these three dots. We click on Open. It is opening. Alright, so now we have all these folders. So source is where you're going to have your scripts, specifically inside this game folder. And on content is where you're going to have your assets. So if you know Unity, you are familiar with this. And so here we're going to have our scene view, which is going to be our hierarchy. And here is going to be the inspector, which is the properties. And here, of course, is the asset browser, where we have our assets. And here is where we add our shapes and stuff. So first of all, I'm going to change this a little bit to have this here because it's easier to drag and drop this first to here. And I'm going to change the game view to there so that I can see what's going on. So first of all, we need a scene. So let's go to content. I'm going to add here a new folder. I'm going to call this resources. On this folder, I am going to add a folder called scenes. And in this scene, I'm going to create a new scene, just call it scene, and let's load it up. All right. So our first Flax scene, good. So I am also going to change the viewport. I'm clicking on the right mouse button and then changing it to this. Right, so there are no game objects here, there are actors in Flax. So we're going to create a new empty actor and we are going to call this actor visuals, so that we can add all this stuff here. We're also going to destroy this floor. I'm going to show you how to do your own. So let's add a new empty actor and call this empty actor environment. For the environment, we are going to create, we are going to create a new actor. Let's call this round. And inside the round, we are going to add a cube. Right. So as how this stands, this is an empty actor, and this is a cube actor. This is a model actor. The model has the cube mesh, and it can have any mesh that you want. So it has no collider. To have a collider, you either go here and then press the left mouse button and add a collider, or you go here and you go onto the physics tab and you drag the collider you want here. We can just leave this collider, it's alright. Round model, round collider. Alright. The Flax Engine also uses centimeters, not meters, which is actually pretty weird to me, but alright. So let's scale this by 20, this by 20. Alright, good. Let's also add this up so that you guys can see this better. Alright, let's create some walls. So we go actor, create empty, walls, we duplicate, child, wall. Here on the wall, we do practically the same thing. We go to basic models, we add a cube. In this cube, we add a collider. So wall model, wall collider. Right, so this is what we have, and we are going to go here and increment to 50. Right, this wall, we are going to position it all the way up front. To snap onto the grid, we can click here, and it will snap here. It will snap exactly where we want, and now we can scale this how we need. 22 seems to be it. Alright, let's have this wall model, As resources, we can create a new folder. New folder, and we shall call this prefabs. We can drag and drop this wall model here, and then we just have to do these rotations. Oh, sorry about that. I didn't want to make this one. I wanted to. So let's break the prefab link. I want the wall prefab, not the models, the wall. So here we have the wall. So this one we are going to rotate by 90 degrees, and this is going to be 0, and here it's going to be this one. Now we're going to copy this one, and then this one. Alright. We got our walls. Let's go ahead and create a new folder called materials. Add a new material. So a material in Flax is a shader in Unity, and the material instance in Flax is what a regular material asset would be. So let's create a material instance, and let's call this walls. This material, we need to select the base material, which I am going to select the default, and let's make this a little bit gray. Save. Let's go on to our prefab assets, and let's just drag and drop it here. If we then onto the model, we then drag, we will see and select here and go to walls, and it is now the walls material. Wasn't tracking, sorry about that. So we've got walls. Let's then create, this is going to be a set environment. Let's then change our camera view so that we can get a better view of what we can do. Let's rotate this by 65. Let's also increment this. Let's go very much up. You can use your camera to change the view. And I don't really like the field of view here, so let's change it a little bit. Okay, this is good, no? What do you guys think? I think this is good enough. Alright. Yeah, this is good enough. Okay, so now let's add our player. Let's go into new empty actor player. So the way this works is we're going to, if you want a physics object, you need, the first actor needs to be a physics object. So I want my player to be a rigid body. So this is going to be player manager, not player. And the rigid body is going to be the player. And for now, this is just a rigid body. It has no shape. Pardon me. To add a shape, we need to add the shape of the collider below as its child. So what I'm going to do is to add a capsule here, which is rather small. Let's increment its size by 2. And then I'm going to go to add collider, and then have the collider a child of the rigid body. So let's go like a collider. Alright. Well, we can go ahead and create an empty actor, which will be our character graphics. Let's have the capsule as a child, and then we can create some glasses with a cube. Just a random cube. Let's just have these glasses here. Let's go ahead and create a new material called glasses. Let's change the color to be completely black. Save. And let's add it to the cube. Right, so to add functionality or scripts, we can add it here. So we can either search or drag and drop a script over there. So let's go ahead back onto our source folder. Let's go into game. Here's where we're going to have all our script. I'm going to create a folder called scripts. I want to have everything inside this folder, this scripts folder, and the folder called player for everything for the player. So C#, we shall add a player script. We shall double click and it will open our inspector of choice. To change the inspector, we go here up top to tools, options, source code, and then we can choose the ones that we want. All right. So here I am going to open up, depending on how you have this set up, it will immediately open up the script. For me, unfortunately, it isn't happening due to my settings. But enough of that, let's check out the script. The script is basically a mono behavior. It has the on start, it also has the on awake. So override on awake. As in Unity, on enable, on disable, on update. This is very much the same as in Unity. And so how do we get our stuff? How do we get our components? So there are two ways. We can either have private variables, so private rigid body, and the rigid body, how do we get it? So on start, override on start, rigid body. Since this actor is of type rigid body, we can go actor dot as, and this will cast this actor as a rigid body. We know that this player character also has a collider. So if we go into public collider, then we will have this property open in the inspector. Let's take a look. So as I said, to add the script, you can either select or drag and drop. I prefer dragging and dropping. So as you can see, the rigid body property is not here, but the collider is. You can actually drag and drop it here, and there should be no problems. When we play, you see that it's there, just like in Unity. So to show this private property, we can actually go show in editor, and it will serialize this property for it to show here. So now we can drag and drop the rigid body also. So we can still have private properties and have them show in the editor, very much like in Unity, which is awesome. Awesome. Another way we could have gotten the collider is we go collider, and since it is a child of this collider, of this actor, we would go actor.getChild, and we cast it as a collider type. All right. So let's get on to the movement. So we're going to have our movements on update. So on update, and we are going to have a method called void handle movement, and we are going to call this on update. So to get our movement, we are going to do very much the same as in how you would usually do it in Unity, and we are going to go on float. We shall need the horizontal input and the vertical input. We then need a vector3 called direction. All right, don't forget to public float speed, and this is going to be in centimeters. To have this translated to meters, I'm going to do something which is float speed, and this is a property which will multiply speed by 100, and then it will be in centimeters. In meters, sorry about that. Let's make the conversion. All right, so let's do this. So we are going to get our horizontal axis, very much how you would get in Unity. So we go input.getAxis. We can either get axis or get axis raw. I'm going for a get axis raw to get that immediate input. Horizontal. Then we're going to go vertical equals input.getAxis raw and vertical. Direction, you probably have already guessed it by now. It's going to be a new vector3, and then it's going to be horizontal, 0 for the y, and vertical for the z. We of course want to normalize this. We don't use this normalize, we use the normalized to get it normalized. All right. So this is how we get the input. Now let's move the rigid body. So we go rigid body, we can add force, like here, to the direction, and we can add the force modes. But I don't really like this. Even in Unity, I didn't like it. It makes it a little bit floaty. So I'm going to go with linear velocity, which would be the same as just velocity in Unity. It is going to be the direction times speed. let's give it a test. So rigid body is null. Let's actually see, you will see that it gets automatically filled, so it is here. Let's increase this so that we can check this out. So as you can see, it is moving. But like in Unity, the rigid body is all messed up due to it having no constraints. So to add constraints to the rigid body, we go here and let's add the constraints for the rotation on the X and on the Y, on the Z, I mean. So we want that and here. All right. So now if we try again, we can see that it is moving perfectly. If we have it, because I'm setting the velocity at 0 on the Y, I cannot pull it up. Good, good. Wait, cool beans, like one guy says, you know who. So let's now make the rotation. So void handle, let's call it handle mouse loop. This has to be called on update. Alright, so to look at the mouse position, we are going to need to raycast. So let's do that. To raycast, we're going to be needing a ray, which is actually going to be camera.main camera dot convert mouse to ray, exactly, and then we go input dot mouse position. It's very similar to Unity. We can also go raycast hit to get the hit point. So then what we need to do, we're going to need to raycast. The way that I like to raycast in Unity and here is to have we can actually have a header here and call it movement. I like to have like a peak collider so that it's more performant and we can just peek on that collider. So what I am going to do is I am going to have here a public property, doesn't have to be public, which is going to be the actor, which is going to be the peak actor, which is basically the transform of the object where it has the peak so that we can move it around. And we are going to need a public collider called peak collider. All right. And on this peak collider, so we're going to go if physics.raycast. You see that we can add the ray. But like I said, I do not want to do, this is just to show that it is possible to just have the raycast. I do not want to use the raycast. I want to go peak collider.raycast. All right, this is where the step is a little bit different. We go ray.position, and the direction we go ray.direction, and then we go out hit. So if this is true, if we have raycast, then we have our position. So we can get our vector3 loop direction, which is going to be the hit point minus our actor current position. So we go actor.position. This will get us the direction. And now to get the quaternion rotation, we go, yes, exactly like Unity, this already knew. And to set the rotation, this is also a little bit different. So we go actor.orientation. We do not go rotation. Rotation is a matrix, and I have no idea what that is. So we go to orientation equals rotation. Let's try this out. So it's compiling. We now can go to environment. We are going to pick a new actor. We are going to call this pick actor. And on this pick actor, I want to have a ground collider, which I'm going to copy and place it here. All right. Pick collider. Awesome, awesome. So we can go here, the rigid body. On the pick actor, we can go pick actor and pick collider here. Let's save this and let's give it a go. As you can see, it is now looking at the position of the mouse. It is raycasting directly onto this collider. And but if we look here nothing is happening. So we need to change that. We need to accommodate for that. So how we're going to do this is that we are going to set the position of the peak actor dot position equals actor dot position. This way we always have this looking at us, so we can look away. If we go too far we can't, so to fix that we need to increment the size of this by a lot. Let's go 50. Oh, let's go 50. Why not? Seems to do the trick. But next thing, what's next? We can have a camera following the player. So let's go on to, let's create a new entity. Let's call it camera manager. Let's add a new actor, call it camera pivot, and then have our camera inside the camera pivot. So what we are going to do is make a new script. We shall call it camera manager. Depending on how you have your engine setup, then you will have different things. All right, so camera manager. We are going to need the pivot, so public actor pivot, and we're going to need a public here, not player. So override on start and override on update. We are going to do some things. So to get the player, I'm going to show you how to get scripts in the real world, in the scene world, I mean. So to get the player, we can go player equals scene times level. It's find script. We will go find scripts, cast that as a player, and this is basically the find component. So we find the script or we find the actor if the actor is a component of something. All right, so on update, if player is equals nulls actually, we are going to return and not do anything. Else, the pivot dot position is going to be vector3 dot lerp from the current position to the player dot actor dot position, and we are going to do this public float speed. It's going to be equals 10, I don't know, and we are going to go speed times start of delta time. Alrighty, let's give it a go. Let's give it a try. So we can go, we can actually add it here. We can add the scripts here. We can have the full, and we can either have the player or just. And as you can see, it is following. We can decrease this. Alright, so on the next video, we are going to continue with shooting, enemy AI, and health. So like and subscribe so you don't miss out.